Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and welcome to my channel. In this video, we're going to discuss about one type of conic section that we call hyperbola. Okay, as we know, conic sections can be divided into four different shapes. We call it. Okay, the first one is an ellipse. Okay, look like this, and this is a circle. Then we have a parabola. Okay, this one. Okay, again, this is an ellipse. This is a circle. This is hyperbola, and over here we have the shape of a parabola. Okay, these different curves, they have their own special names, and not only that, they have their own properties. Okay, their own graphs, and they have their own equations. All right. Now, maybe here we would like to talk about the orientation of these different shapes, right? The orientation. Okay, how many orientation for each type of conic section have? For example, for a circle, okay, that is this shape here. No matter how you rotate, okay, you rotate or you reflect or whatever you do with a circle, it will be still the same circle. So we say that a circle has only one orientation. Now for ellipse for ellipse, that is this shape here, we can have ellipse of this orientation, that is we call it vertical, and also we can have a horizontal ellipse, that is something like this. Therefore, ellipse have two orientation. One is vertical, okay, that is this one, and the other one is horizontal. Okay, and we refer to the major axis. Okay, remember we have in ellipse we have major axis. So for the vertical one, we call this ellipse having vertical major axis. Now for this ellipse, they have horizontal major axis, right? What I mean to say here is that ellipse have two orientation. Now for a hyperbola, now we want to check how many orientation that we have. Now if we look at this figure here, this diagram, okay, this is one orientation, that is, okay, together one of them facing to the right, that is this part, and the other one is facing to the left, this component. Okay, one facing to the right, the other one facing to the left. Now these two shapes together, this what we consider this as one orientation. That is, we have one facing to the left and one facing to the right, like that. Now the other orientation that we have is one is facing up and the other one facing down. Okay, that would be another orientation. Therefore, we say hyperbola have two orientation. Okay, now the last one is the parabola. Now we want to know how many orientation that a parabola have. Now one of them is like this. That is, the parabola is opening upwards. Okay, that's one. So let's draw. One is facing up like that. The other one is facing down like this. Okay, we have a parabola facing to the right like that. And also we have a parabola facing to the left. That is like this. So how many orientation do we have for parabola? 1, 2, 3, 4. Therefore, we have 4 orientations. There are many more actually orientation according to angle like that, but we are not going to consider that. Okay, in algebra course, we usually talk about parabola with 4 orientations like that. Okay, go facing up, facing down, facing to the right, and facing to the left. Okay, now maybe we can ask the question about the conic section itself. Conic section. Okay, about the name of this concept, conic section. Now, what we mean by conic here is from the word cone, from cone, meaning these four shapes that we are talking about, that is ellipse, circle, hyperbola, and parabola, all of them, they are coming from the shape of a cone. That is, for example, an ellipse. Okay, if we have a cone, and we cut the cone at a certain angle, for example, like this, we are going to have an ellipse. Yes, therefore we say ellipse is a conic section because we get it by slicing, by cutting a cone at a certain angle. Then we have an ellipse. Now, how about a circle? Yes, we can have a circle from a cone. Now, if you have a cone, for example, ice cream cone, for example, you can look from above, from the top, you can see that is a circle. Or you can say like this. Okay, if we have a cone, then if we cut, okay, the cone horizontally by a plane like that, then we have a circle. Now it depends where you do the cutting. If you do the cutting down here, you will have a smaller circle. But if you do the cutting very close to the top, then you have a bigger circle with bigger radius, of course. Now, for the third type of conic section, we call a hyperbola. Okay, in this case, we need two cone that arranged in such a manner. One is facing up like this, and the other one is facing down. Now what we do the cutting. Okay, vertically. Okay, through the first cone and also the second cone. Therefore, we are going to have two shape. One is facing up and the other one is facing down. They come together. Now, if the vertical, I mean the cone is arranged vertically like this, okay, we have one is facing up and the other is facing down. But if we make the cone lie down on a table, for example, and we do the cutting horizontally, we are going to have, okay, a hyperbola with two components. One is facing to the right, and the other one is facing to the left. Okay, and together, still we call it a hyperbola. They have two components. All right. Now, parabola, we can also, okay, create a parabola from a cone like this. If we do the cutting in this manner, in this way, we are going to have a parabola like that. So that's why we say these four shapes, they are conic sections because these different shapes coming from a cone. So now let's talk about the equation of a conic section. Okay, very interesting in this part because okay, any conic section, they have the same, almost this. I mean, they have the same general equation. We can put them together. I think the reason is that because they are coming from the same object. It is a cone, right? Therefore, when we write down the equation, okay, each one of them can be written in this form. That is ax squared plus cy squared plus dx plus ey plus f equal to 0. This will be the general equation for any conic section that we talked about just now. Four of them. Okay, either it is a circle, ellipse, hyperbola, or a parabola. The general equation, they are the same. Now, with the condition that the value of a and c cannot be both equal to 0 simultaneously, cannot. Okay, one of them can equal to 0, but cannot both. Okay, one of them must not equal to 0. All right. But for each one of the conic section, they have a special properties. That in particular the value of a and c. Okay, let's talk about that one. That is for a circle. For a circle, okay, the value of a and c. So this is another part that is very interesting. For each one of these, okay, the only thing that we have to look is that the value of a and c. For a circle, the value of c, okay, the value of a and c must be of the same value. Same value. That is, if we see the value of a is, for example, 5, c also equal to 5. Now, regardless the value of d, e, and f, we know that this equation represents a circle. How can we say that? Because the value of a and c is of the same value. Okay, that's the only indicator. Okay, from the general equation that is represent a circle. What is it? A and C have the same value. Maybe A equal to 1, C also equal to 1. All right, then we know this is a circle. Okay, that's for a circle. Now, how about if we have ellipse? Ellipse. Now, what is the value of A and C? Okay, now for ellipse, the value of A and C must be of the same sign. Same sign. What we mean same sign here is that in terms of positive and negative. Okay, if A is positive, for example, C also must be positive. Okay, meaning to say both of them positive. A positive, C also positive. Or the other way around, we can have A negative and C also negative. Same sign, right? Okay, therefore that equation will represent an ellipse because they have the same sign. All right, so that is the indicator that the general equation represent an ellipse when they have the same sign. We just look at the value of A and C only, right? The next one is the hyperbola. Hyperbola, that is the shape that we are going to discuss in detail in this video. For hyperbola, the value of A and C, if in ellipse they have the same sign, if in ellipse, okay, it's the same sign. Now, in hyperbola, A and C must be of opposite, opposite, opposite sign. That is, if one of them is positive, the other one must be negative. Opposite, right? Now, if C is negative, for example, A must be positive. If A is negative, C must be negative. They have this different, opposite sign. Okay, one positive, one negative. All right. Now, the last one is the parabola. Now, still we are looking into the value of A and C. Now, in parabola, one of them must be 0. What I mean to say is either A equal to 0 or C equal to 0. Meaning one of them must be equal to 0 in order for that equation to present a parabola. Meaning to say, if we look at this equation here, one of this equation, I mean this first two equation, okay, this component x square part and also y square part, for a parabola, one of them is missing. For example, okay, when we see the equation, we don't have x square component. Oh, then we know that equation is an equation representing a parabola. Or maybe this component involving y square is missing. Okay, we have only ax square and then plus all these other component. That's also telling us that that equation represent a parabola. That is either a0 or c equal to 0. Okay, now maybe we can start looking at the graph of a hyperbola. We have two graphs of a hyperbola. In this case, it's the blue one. They have two components, two parts, two slices. One is facing up like that, and the other component of this hyperbola is facing down. So together, okay, they represent a graph of a hyperbola, right? Now the other one that is the red in color here, we have one is facing to the right, the other one facing to the left, right? Together, they also represent a hyperbola. Now, maybe we can highlight some of the important properties of a hyperbola. That is number one, they have what we call vertex. All right, this is, look here, this is vertex. All right, vertex. Let me write it again. Vertex like this. Okay, that's vertex for that left hand side part. Now, on the right hand side also here, this is also we have another vertex. This is also another vertex. Meaning to say, any hyperbola, they have two vertex. Okay, now for singular, we call it vertex. When it's plural, more than one, we call it vertices. Yeah, vertices. So a hyperbola, they have two vertices. Okay, one is on the left and the other one is on the right. Now, beside vertex or vertices, a hyperbola also they have what we call center. This point here, we call it center. C-E-N-T-E-R, center. Okay, that is midpoint, halfway between vertex 1, usually the left one we label as, the right one here we label as V1. V for vertex. Okay, V1, vertex number 1. Now, on the left hand side, we call it V2. That is vertex number 2. Now, halfway, okay, if we go from vertex 1 to vertex number 2, okay, the midpoint between V1 and V2, there is a point there. We call it a center. And usually, we represent a center by a symbol C. Center for, C to represent the coordinate of the center. Now, the line, okay, let me draw the line by using red in color. The line joining, okay, V1 and V2 passing through the center, that is this line that I'm drawing now, this line, okay, has a name, very important name. This line is called transverse axis, like this, transverse axis. And usually, when we talk about the orientation of a hyperbola, we refer to the transverse axis. Like in this case, okay, this hyperbola having horizontal transverse axis. You see the axis here, the transverse axis is horizontal, right? So we say this hyperbola having horizontal transverse axis. Okay, I hope you get my point there. Now let's focus on the other graph and the blue color graph here. Now, can you tell me where is vertex number 1? Okay, if this graph vertex number 1, we take the vertex on the right hand side. Okay, for the graph of this type, one is facing up and the other one facing down. Our V1 will be the one facing up. That is this one. So we are going to label this as V1. Okay, the one facing down for the graph facing down, we label that point as our V2. This is our V2. Now, where is the center for the blue graph? Yeah, the midpoint, halfway between V1 and V2. And that point, the center will be that one, that point. This is C. Okay, and where is the transverse axis for the blue graph? Yeah, this point, this line that is joining V1, C, and V2. Okay, so I'm going to label this line as the transverse axis. Yeah, all right. So that is the transverse axis. In this case, it is on the y-axis. Okay, now the previous graph, that is this one, the red graph having transverse axis on the x-axis. Okay, x-axis mean the transverse axis is horizontal for this one. For the blue graph, okay, they are having vertical transverse axis. Right. So that is some important point concerning hyperbola. That is the vertex, that is V1, V2, the center, and also the transverse axis. There is another point that is important in a hyperbola, that is we call the focus. All right, we already talked about the vertex. Okay, in this diagram, now let's label where is our vertex. This is V1. I hope you can see that V1. This is our V2. This is V2, vertex number 2. All right, this is the center. In this case, the center is at the origin. See, that is having coordinate 0, 0. Now, do you see F1? Okay, now I want to change. Now, instead of labeling F1 on the left hand side, I'm going to label F1 will be, okay, the midpoint, the focus point on the right hand side. Okay, this one will be our F1. This is our F1. Okay, this is not our F1. F1 is on the right hand side. So this will be our F2. Our F2. So we are going to be consistent. V1 and F1. Now the focus point, if the graph is facing to the right, the focus point is inside, okay, the graph like this. Okay, the graph is facing to the right, the focus is inside. The graph is facing to the left, this component, this part, therefore the focus F2 is inside here, right? So these are also important point for a hyperbola. So let's write everything that we need in order for us to know about hyperbola. Number one, we have two vertices. Okay, we have two vertices. We have one center. What else? We have we have two what? Two focus, or we call it plural foci. Okay, we have two foci, and we have what we call asymptotes. Yeah, let's talk about asymptotes. We have two asymptotes. Asymptotes. Two asymptotes. Okay, that is the line. Okay, the dotted line here. This is the dotted line. That is our first asymptote. Okay, that is the graph is getting very close to that line but never touch. Okay, either this way or this way. The same thing, we also have another asymptote, this line, dotted line also. Okay, this graph on the left hand side getting very close to that line but also never touch. Okay, and the same thing down here. The graph is getting very close to the dotted line, that is the asymptote, but never touch. That is the what we call the properties of asymptotes. Okay, the graph is getting very close to it but never touch, as the value of x is going to approach to positive infinity to the right. Okay, x is going or approaching negative infinity to the left. The line getting very close to the asymptote but never touch. All right. Okay, so that's about it. So next, we can discuss about the first type of equation. Now we are going to talk about the standard equation. Previously, we talked about the general equation of a hyperbola. We are going to give more give more examples after this. But let's talk about first the standard equation. The first one is this one: x square over a square minus y square over b square equal to 1. So this equation, if we sketch the graph of it, it will be this graph. See, horizontal transverse axis. That's why we see here hyperbola with horizontal transverse axis with center at 0, 0. That is at the origin. The center is at origin and the graph having horizontal transverse axis. So we always refer, when we talk about the orientation of a hyperbola, we refer to the transverse axis, whether it is horizontal or vertical. In this case, the transverse axis is this one. Let me draw by using red color. This one. This is the transverse axis. This is our V1, this is our V2, and this will be the transverse axis. And this is the center. The transverse axis is horizontal. So this is the graph we say the hyperbola with transverse horizontal transverse axis with center at 0, 0. You see here, please take note that x square component is up front, followed by a negative sign, and then we have y square over b square. For x square, we have divided by a square, and the right hand side we have equal to 1. So an equation of hyperbola always on the right must be equal to 1. The left hand side is depend. Sometimes we have x square in the front, and sometimes we have y square in the front. See here, please take note that when x square is in front, the graph is having horizontal transverse axis. The graph is horizontal when x square over a square is in front. The center is 0, 0. Now the vertices, V1 is the coordinate of it will be A0, meaning the distance between center and vertex number 1 is A. That value is A. Now the distance between the center and V2 also A. Therefore, the length of a transverse axis is equal to A. Let me write it down here. The length of a transverse axis is equal to 2A. because we have a plus a to a, right? Okay, so the coordinate of v1 will be a 0, and the coordinate for v2 will be negative a 0, like that. Okay, and this will be the asymptote, the dotted line, right? This is the asymptote 1, and this is the another asymptote. Okay, all right. Now we talk about the focus just now, the focus point. So now to plot the point for focus, either focus 1 or focus 2, f1 or f2, we need the value for c. And the value for c we can get from this equation, that is c square equal to a square plus b square. Okay, this is like the formula for Pythagoras theorem, right? So c square equal to a square plus b square, then we can find the c from here. Okay, once we have that c, the coordinate of f1 and f2, okay, for 1, f1 will be c0. Okay, meaning, now let's refer to this graph, this one, all right? This graph here, let's look at this graph. Now this is the center. Okay, this is the center, that is the point 0, 0. Now to the right we'll have our v1. This is our v1, right? Now this focus point we label as f1, and the coordinate will be c0. That means that the distance between the center to f1 will be the distance equal to c. Now the same thing happened on the left hand side. That is the distance between the center and focus number 2. Okay, this our f2 here, this point will be c also. All right, now the distance between the center and vertex is equal to a, right? This one, the distance between this center to this vertex also equal to a. I hope you understand where this a, this a come from, the value of a. You see, we have to refer to that equation again. You see, we have x squared over a, right? Or over a square. So we can get the value of a from this value a square here. All right. Now we are going to talk about the value for b in a short while. Okay. Now the next type of hyperbola is a hyperbola having center at point hk. Center at hk, not only at 0, 0. Okay, when the center is at 0, 0, at the origin, that is a special case. But sometimes the center can be anywhere, in the coordinate system. Can be, for example, at 1, 4, maybe sometime maybe the center at -7, -2, and so on and so forth. Okay, not necessarily the center at 0, 0. It can be at any point. So what happened in terms of the equation is the equation of the hyperbola having center at hk will look like this: x minus h square over a square minus y minus k square over b square, still equal to 1. The right hand side always equal to 1. Okay, I hope you notice that. So this is for a hyperbola with horizontal transverse axis with center at hk, right? So the vertices will be v1, and the formula for v1 will be the x component x h plus a k. For v2 will be h minus a k. Okay, that's the coordinate of v1 and v2. All right, the coordinate for focus f1 and also f2. Again, we need the value for c using the same formula again. C square equal to a square plus b square. And then after we get the value for c, we can substitute into this formula. We can find the coordinate for f1 and also the coordinate for f2. The only difference is that here we have h plus c. For f2 we have h minus c. Okay, the y part is still the same, that is the value for k. Now this is the equation of the asymptote, that is k plus minus b over a x minus h. We can break it down into two equations actually. because we have two asymptotes, right? Okay, the first one is actually y equal to k plus b over a, okay, x minus h. This is the first equation. That is, this asymptote is having positive slope or positive gradient. Now, the second asymptote having equation y equal to, we take the negative sign this time. So, k minus b over a x minus h. Okay, having gradient or slope equal to negative, the one facing to the left. Okay. All right, this is the equation of the asymptote. We don't need to remember this formula because when we sketch the graph, we can do it differently by constructing a rectangle. Okay, and we didn't have to memorize this formula because it's kind of complicated to memorize the formula, right? Now, the other types of hyperbola, okay, the other type of, orientation of it, that is facing up and facing down, where in this case we have a hyperbola with vertical transverse axis center at 0, 0. You see here in this diagram, we have the hyperbola. One is facing up and the other one is facing down, right? The previous one is facing to the left, the other one facing to the right. All right. Now in this case, the center is still at origin, that is 0, 0. That is this point. So our V1 is this one. This is our V1. All right. This is V2. Right. The coordinate of V1 is 0A. Remember where we get our A? Here, the value of at the denominator of y square, see y square over a square. From a square, we can get a. Okay, and that's the value of a will be the distance between the center and the vertex. Okay, so we have that one as a. Now, in this diagram, I would like to show to you what this b square mean. Now, from b square, we can find the value for b, right? We can find the value for b. Now, what is that b? That value b represent? Now, b actually is the what we call the length between the center to the right hand side. Now, see here this point. This point is b0, right? Therefore, this distance, the distance between the origin to this point is actually b. Where we get this b? We get it from here. Okay. The distance between the center and the vertex is a, right? Where you get a? You get it from here at the denominator of y square. Now, when y square in front, I hope you notice this one, very important. When y square is in front, followed by negative sign, subtraction, and then we have x square component. Y square is in front. That means, okay, this graph is a hyperbola with vertical transverse axis. Vertical, meaning one is facing up and the other one facing down. Okay, and the center is still at 0, 0. Vertex 1 is 0a because it is on y-axis. So 0a, whatever the value for a is. Now V2 will be 0, negative a. Down here, 0. Okay, the y component is negative a. That should be the coordinate for V2. Now, maybe we better highlight the point or the coordinate for focus 1 also. We have 0C. Okay, up here we have F1, 0C. This is the coordinate. This is the point. Now, F2 will be this point. That is 0, negative C is the coordinate for F2. Okay. So, what we do in order for us to what we call to draw the asymptote of a circle, of a hyperbola, what we do is that we construct this rectangle, this one, because we already know the value for A and B. Okay, therefore we can construct this rectangle. We construct this rectangle, construct like this. Okay, this is A and this is another A. Okay, this is B, this is another B, this is A, this is another A. So therefore we can construct this rectangle. And then to draw the asymptote, what we do, we take a ruler, okay, we take our pencil, and then join this point and that point together. What we call this end point, this point and this point, okay, and then we draw a dotted line, okay, joining these 2 points together, and therefore we have our first asymptote, that is this line here, right? Now for the second asymptote, we do the same thing, but we do the same, I mean the opposite point, this point and that point, join them together using pencil and a ruler, then we have our second asymptote. Okay, so we have both asymptotes, and when we sketch the graph, we draw a what you call smooth curve approaching the asymptote but never touch, and then don't forget to draw the arrow at the end of the graph like this. Okay, also the same thing down here, we have the arrow, one is facing up, the other one facing down. All right. Okay, now to plot the point of focus 1 and also focus 2, we have to have the value for C. Now C can be calculated using this formula again, the same formula, never change, A square plus B square equal to C square, and we can find the value for C. Okay, and the coordinate for C is up here somewhere. This is our point F1. Okay, this is our F2. Okay, so when we draw the graph or hyperbola, don't forget to write down the coordinate of F1. Okay, this is the coordinate for V1, this is the coordinate for the center, this is the coordinate for V2, the coordinate for F2. We have 5 of them all together, and we draw the asymptotes. Okay, but before that we have to construct the rectangle first, this rectangle, and then we join this line together, we have the first asymptote, we join this point and this point together to get another asymptotes, like that. So that the process that we have to go through to draw a graph of a hyperbola like that. So this is an equation of a hyperbola with vertical transverse axis with center at HK, right? So the formula becomes like this. I hope you notice here we have y minus k square in front, y minus k square over a square in front, meaning the graph is vertical. One is facing up and the other is facing down. Okay, that's the way how to notice, how to decide whether the graph is facing up and the other is facing down. How to tell? If y square is in front, we see it and we know the graph is vertical. Now, if x square component is in front, then we know the graph is horizontal. One is facing to the right and the other one facing to the left. Now, the same thing, we can find the the focus point, that is F1 and F2, by using this formula that relate C with A and B. That is C square equal to A square plus B square. Now let's do this example so that we can understand the process of sketching the graph of a hyperbola. In particular, if we are given the equation like this, y square over 16 minus x square over 9 equal to 1. Now, can we tell whether this is an equation of a hyperbola or not? Yeah, this is an equation of hyperbola. In fact, this is a standard form, right? Because we have y square component, we have x square component, and in between we have minus sign, and the right hand side is equal to 1. We already recognize the shape or the format of the equation in standard form for a hyperbola. That is, we have y square component followed by x square component, and in between we have subtraction, and on the right hand side we have equal to 1. So what we can get from this equation? Any information we get from this equation related to the hyperbola? What we have? Yeah, we have a square equal to what? Yeah, a square equal to 16, right? This is always a square. All right. So a square equal to 16. Therefore, a equal to 4. In fact, actually, we have a equal to positive and negative 4. Okay, we had to reject negative 4. Why is that? Yeah, because a is a distance, right? Distance between the center and the vertex. And the distance cannot be negative. Okay, that's why we reject the negative value. So we accept only a equal to positive 4. Alright, so we have a equal to 4. Done already. Now we have this 9 here. What is that 9? That value 9? Yeah, that's b square. B square equal to 9. So what is b equal to? Yeah, b equal to 3, right? Square root of 9 is equal to 3. And also we reject negative 3. Now we also need to calculate what is the value for c. That is the distance between the center, okay, the center and the focus point. Alright, so how to calculate for c? Remember, c square equal to a square plus b square, right? And a square is equal to 16 plus and b square equal to 9. So we have 25, that is c square. Therefore, c equal to square 25 is equal to 5, right? So we have a equal to 4, b equal to 3, and we have c equal to 5. Now, what else we know from this equation? From this equation, what else we know? Okay, we know this is hyperbola. Hyperbola. Okay, this of course we know. What else we know? The center, right? Yeah, the center is at what? At 0, at 0, 0. Center is at 0, 0. So I think that's all information that we need. That is the center, value for A, B, C, and the the shape here. Okay, confirm that is a hyperbola. Now, the next question maybe we want to ask is, okay, is this hyperbola, okay, with transverse axis vertical or is it horizontal? Now, what we have to check is what is in the front, right? Is it y square or x square in the front? In this case, see here, we have y square in the front. Y square over 16 minus x square, meaning y square is in front. So we know this is, okay, the hyperbola is what? Yeah, this is vertical, sorry, vertical. Okay, transverse axis. Vertical transverse axis, meaning the graph will be one is facing up, the other is facing down like this. Okay, facing up and facing down. So we have to keep that in mind. All right, so let's sketch the graph of this. Maybe in this coordinate system here, we maybe can write down again. We have the value for A 4, 4, 3, 5. Yeah, A equal to 4, B equal to 3, C equal to 5, and the center is 0, 0, and the graph is transverse axis is vertical, meaning the graph is facing up and facing down like that. So let's plot the point of 0, 0, that is the origin, as the center of this hyperbola. This is, okay, the origin. All right, so A equal to 4. A equal to 4. Remember, this graph is vertical. So A equal to 4. That's the value of V1 must be on y-axis. So we are going to move 4 units upwards. So this will be our V1. Let's label that as V1. Going down will be our V2. 4 units also. So this is V2. Okay. Now we can also mark the point of F1 and F2. Okay, 5 unit going up. So that's 4 unit already. So 5 will be somewhere there. So this is F1. Negative 5 is somewhere here. This is F2. All right. Now I want to also draw the line to show that B equal to 3. Okay, 1, 2, 3. So this is the point B to the right, and that is 3 to the right and also 3 to the left. What I want to do now is I want to construct the rectangle. So what I want to do is first I want to draw this dotted line like that. This one also I have to pass through this point. B equal to 3, so pass point 30, and then I have to go to the right like this, like that. This one use okay, when you draw this, draw using a pencil and ruler. So I already construct that rectangle. So what I want to do now is I want to draw my asymptote first. Okay, so this is the point, and this is the point that I want to connect between them by using a ruler and pencil. So what I will do, and passing through, okay, passing through the center. So what we'll have is, maybe I want to use different color, like this, more or less like that. And also we pass through this point on at the bottom. All right, that's one. Okay, this will be asymptote. Now we have another one, that is, one is going down like this, like that, and the other one will pass through that point. So use your ruler and pencil carefully. Okay, now I want to sketch the graph now. So this is the asymptote, right? Asymptote. Okay, so now I want to sketch the graph by using different color. I want to use green this time. So we'll pass through the vertex V1. So this part will go this way, and we're getting very close to the asymptote, but never touch, like this, like this. Okay, that's to the right hand side. Now to the left hand side, the graph also getting very close to asymptote, more or less like that. And we have the arrow. Okay, that's facing up. Okay, the other part of the graph, the component is facing down. Okay, and have to pass through point V2, vertex 2. So I want to start from there and going down, getting very close to the asymptote, like this. Okay, and another one this way, like that. Now I want to label the coordinate of each of this point. Five of them all together. That is the center C 0 0, right? Okay, F2 is what? F2 is 0, negative 5. V2 0, negative 4. F1 will be 0 5, and V1 equal to 0 0, yeah, 0 4, like that. And this will be the graph of this function, or this equation, that's y squared over 16 minus x squared over 9 equal to 1. Okay, that's the graph of it. Now let's continue or proceed to the next example. That is this equation, or this problem here. Sketch the graph of this equation, that is 16x squared minus 9y squared plus 64x plus 54y minus 161 equal to 0. Now, I hope you notice that this equation is not in standard form, all right? And it is in general form. The only thing that we know is that the value of A, here is A, right? And here is C. See, A is positive, right? A is positive, and C is negative. A and C having opposite sign. That means that this equation represent a hyperbola, because we already mentioned if the value of A and C, they have different sign, that is one of them positive and the other one is negative, then this equation represent a hyperbola, not a parabola, not a circle, of course not an ellipse. It is representing a hyperbola. That's the only information that we know from this general equation. Now, to know the circle, the value for A, okay, we also need the value for B and C and so on and so forth. Now, what we have to do is we have to convert, okay, the equation from general equation to standard equation. Okay, in order for us to do that, we need to know what we call completing the square. Okay, let's do that first. Okay, let's write it down again. The equation, we have 16 x squared plus 64x minus 9y squared plus 54y. Okay, let's write down 161 on the right hand side of the equation, 161 positive, right? Now first let's consider the terms with variable x only first. So we can factorize. See here we have 16 and we have 64, right? We can factorize 16. What's left in the bracket, we have x squared, and 16 times 4 is equal to 64x, and we have to add with one number there, right? Now between negative 9 and 54 we can subtract 9. What's left is we have y squared in bracket. Of course we have to have negative there to have positive 54. 9 times 6, okay, negative 6y, and plus 1's number there equal to, we have 161 plus, okay, plus, okay, we are going to add the same number to the right hand side also. Now the question is, what number, okay, goes to this blank space, and also what number should we write in this blank space? All right. Now that is the process of what we call completing the square. What we have to do is this number 4 divide by 2. Okay, 4 divided by 2 is equal to 2, and then square that number. 4 divided by 2 is equal to 2. 2 square is equal to 4. So we write 4 here. Okay, now for the second blank space that we have, now this number is 3, right? 3 divided by 2 is, not 6. 6 divided by 2 is 3. Now 3 square is equal to 9. Therefore we write 9 in the second blank space. Now I want to, okay, write down the same number to the right hand side. What happened here is that we should not write only 4 and 9, because we have outside the bracket we have 16. So 16 times 4 is 64, right? So what we have to do is we have to plus 64 there. Now how about the second number? We have negative 9 multiplied by positive 9, negative 81, right? So what we have to do is we have to add negative 81 on the right hand side. Okay, so let's finish up this completing the square process. So we have 6. For this one we have x minus 2 square. We have the next term is negative 9. We have x minus 3 square equal to, now simplify all this term on the right hand side, we have 144. Now is this in standard form yet? Not yet. So what we have to do is we have to make the right hand side must equal to 1. So we have to divide by 144. This also we have to divide by 144. This term also we have to divide by 144, like that. So if we do that, so what's we have now is we have x plus 2 square, okay, we have over 9. Now minus, we have x minus 3 square over, over 16 equal to 1. Okay, now we have the equation of hyperbola in standard form. Okay, from here we can write the information concerning the hyperbola. That is, the center is at negative 2, 3. The value of a is equal to 3, right? The value of b equal to square root of 16 is equal to 4. Now, what is the value for c? C square equal to a square. That is 9 plus 16 equal to 25. So c equal to 5. Okay, the center we have A we have, B we have, and C we have. And let's see what is the orientation of the graph. Is it vertical or is it horizontal? By looking at this. By looking at this equation, can we tell whether the graph is horizontal or vertical? Ask ourselves what is in front. Yeah, x square component in front. Therefore, the graph is horizontal. Horizontal transverse axis, meaning the graph will be one like that, the other one facing to the right, the other one facing to the left. Okay, 3, 4, 5, negative 2, 3. So let's write it down again here. Center is negative 2, 3. A equal to 3, B equal to 4, C equal to 5, and the graph is horizontal. What else we have? Let's see, A, B, C, 3, 4, 5, negative 2, 3. Negative 2, 3. Yeah, so I copy, that's correct. Okay, now let's plot these points. First, the center of it, that is negative 2, 3. Negative 2 and go up 3. That point. That should be the center. A equal to 3. Okay, A equal to 3. Now, should we go to the right, to the left, or going up or down? Yeah, since the graph is horizontal like this, so the vertex will be on the right and also on the left. So we have to go to the right, 3 units. So 1, 2, 3. So this will be our V1. Okay, let me write it over here. This is V1. Okay, go 3 unit also to the left. 1, 2, 3. This my V2. Okay, now I have to go up 4 unit. 1, 2, 3, 4 will be this one. 4 unit going down. 1, 2, 3, 4. So now I want to construct the rectangle like this. Like that. So I have to go down also. Go this way. Like that. Okay. So now I'm ready to draw the asymptotes. Okay, passing through this point. Okay, make sure you use your ruler when you sketch all these lines, because they are straight lines, so better use ruler. So I want to connect now that point and this point like this. Roughly one is going that, sorry about that. Okay, so vertex one is this one, so our graph is one is to the right like this and the other one to the right. One graph is going to the right like this and the other one going to the left. Okay, and getting very close to the asymptote but never touch, so I want to use color, red color. So the graph will be like that, going, okay, and also going, sorry about that, like this, right? That's the graph facing to the right. Now facing to the left, like that, and the other one is going this way. Okay, now let's write down all the coordinate we have. Okay, the coordinate of center is negative 2, 3. Okay, V1. Okay, V1 is equal to 1, 3. This is 1, 3. Okay, and this one is negative 5. Negative 5, 3. Center, and also we have focus. Focus is 5 unit, so we have to add 2 more unit. 1, okay, 1 and 2. This point. So this is my F1, that is 3, 3, 3. Now 2 more unit to the left. 1, 2. Over here we have negative 7, 3. This will be F2. Okay, I think I complete the what we call the labeling all the points, the importance point, I mean. Okay, that's how we sketch the graph of this equation. Okay, given the general equation, we have to convert first to standard form, and then we can get all the information, and then later on we can sketch the graph. Now these are two examples, or two exercises I mean, that we can try. That is y minus 6 square over 36 minus x plus 2 square over 64 equal to 1. That's already in standard form. For part B, we have 49 x squared minus 25 y squared minus 588 x plus 200 y plus 139 equal to 0, given in general equation. Now, how to solve this problem? Now, please follow the example that I have shown to you. Hopefully you can try this equation and see whether you can sketch the graph of of the hyperbola represented by these two equations. I think that's all for now. Hope you to see you next time. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.